Welcome to Curiosity. Take a look around you right now. It feels like you're experiencing the world exactly as it happens. But the truth is, everything you are seeing, hearing, and feeling has already happened. When a batter steps up to the plate and reacts to a 100-mile-an-hour fastball, the subjective experience is one of absolute, instantaneous synchronization with reality. But physics and biology get in the way. Light and sound take time to reach your sensory organs. Then your nervous system has to capture those stimuli, convert them into bioelectrical signals, and route them through complex neural pathways before you actually perceive anything. If humans waited for raw, unedited data to reach conscious awareness before moving, that baseball player would strike out every time, and our ancestors trying to evade a predator in the wild would consistently fail to react in time to survive. Our nervous system has a strict biological speed limit. Because of this, the seamless, real-time world you experience is actually a highly orchestrated illusion. In the mid-19th century, a physicist named Hermann von Helmholtz successfully measured the speed of nerve conduction. Before him, scientists assumed sensory transmission was instantaneous. Helmholtz proved it wasn't. It requires a measurable amount of time for a signal to travel through the human body. A century later, researcher Benjamin Libet took this further, using EEG technology to monitor participants flexing their wrists. He discovered that the brain subconsciously starts building up the electrical potential to move well before the person actually decides to act. This table breaks down the specific neural delays. Look at the bottom row. Every synaptic crossing compounding the lag, resulting in a motor readiness potential that begins building up roughly 500 milliseconds before you report any conscious awareness of your intent to move. Because signals travel through biological tissue at finite speeds, we cannot experience the absolute present. This physical latency introduces a massive engineering problem for the nervous system. Different senses process information at completely different speeds. This document highlights the stark difference in biological pipelines. Sound waves strike the eardrum and reach the auditory cortex in just 10 to 15 milliseconds, but visual processing is slower. Photons must pass through a multi-layered retinal circuit before traveling to the primary visual cortex, taking anywhere from 50 to 80 milliseconds. To fix this asymmetry, the brain actively buffers the incoming signals. It holds that faster auditory data in an internal waiting room for up to 80 milliseconds, pausing until the slower visual information catches up. If a sound and a sight both arrive within that temporal window, your brain strips away their actual biological arrival times. It then forces your conscious line to perceive them as happening at the exact same instant. Your brain operates as a post-production editor, constantly syncing mismatched audio and video feeds to provide a coherent stream of consciousness. It gets stranger when you consider how we see. When you scan the room, your eyes don't glide smoothly. They execute rapid, violent jumps. If the brain processed this raw visual data, your vision would be a constant, nauseating blur. To prevent severe motion sickness, your visual cortex simply shuts down during these movements. Because of this mechanism, you spend roughly 40 minutes to an hour of every single day completely blind. You never notice these rolling blackouts thanks to a phenomenon called chronostasis. You might know it as the stopped clock illusion. When you quickly glance at a ticking clock, that very first tick appears to hang in the air slightly longer than the rest. That pause happens because the brain captures the clear image of the clock after your eyes stop moving, and then retroactively stretches that image backward in time to fill the blind spot created by the eye movement itself. Your sense of continuous time is an artificial patch. Your brain is actively rewriting your immediate memory to hide its own downtime. Operating on a permanent delay with frequent bouts of temporary blindness should make it impossible to navigate a fast-paced physical environment. So how do we manage it? We manage it by guessing. A famous laboratory experiment called the flash lag effect illustrates this perfectly. If you watch a ring moving continuously across a screen and a sudden flash of light appears exactly inside the center of that ring, you won't actually see the flash in the center. You will perceive the flash lagging significantly behind. Recognizing the steady path of the ring, your visual cortex projects the object's position forward in time to compensate for its own processing delay. But the sudden flash is unpredictable, so it gets processed with the full biological delay, creating a clear spatial mismatch in your mind. This theory defines the brain as an active prediction machine. It constantly projects internal hypotheses about the environment, using raw sensory data primarily to correct errors in its own pre-calculated models. What you experience as the present is not raw feedback from the outside world. It is your brain's highly optimized, pre-calculated simulation of what it expects to be happening right now. Modern high-resolution neuroimaging confirms that this simulation isn't even a continuous flow. The brain samples the environment in discrete cycles. Sensory information is captured, packaged, and processed in distinct 100-millisecond frames. Understanding these precise prediction algorithms is actively reshaping technology. Next-generation brain-computer interfaces are being designed to anticipate a user's intent based on those pre-conscious readiness potentials, bypassing our natural biological delays to achieve instantaneous control. In virtual reality, developers are mitigating motion sickness by targeting our natural blind spots. By engineering rendering engines to update displays precisely during those specific moments of saccadic suppression, they can create perfectly seamless digital environments. In medicine, we are realizing that disorders like schizophrenia represent breakdowns in this exact predictive system, where the brain fails to recognize its own internal thoughts as self-generated, resulting in auditory hallucinations. Mapping these biological processing delays has evolved from a philosophical debate into the literal blueprint for future human augmentation and targeted neurological therapies. So, the next time you catch a fallen object or hold a conversation, consider what is actually happening behind your eyes. You are not a live audience to the universe. Your nervous system is constantly hiding its own processing delays, smoothing over temporal gaps, and projecting an artificial, predictive version of reality just so you can survive an unforgiving physical environment. Your brain is lying to you every single second, but it is a meticulously engineered, survival-driven simulation of the past, making it the most beautiful lie in the universe.